Hello, my young friends. I'm Javashri Ghosh, teacher, Demonstration Multipurpose School, Bhubaneswar. Children, I welcome you to my science class. I'm really interested to come back and interact with you all. We have done with the matter in our surroundings 2 parts. Today is the concluding and the third part of this chapter. We'll learn certain more new concepts. I think children, you had listen to me like in the last class I told you to go through the book. I think you have done it. And you're well prepared for the third part now. Let's start. Be ready with your notebooks and pen. Children, in previous classes, what did we study? We studied about the change of state of matter. Is not it? From solid to liquid, liquid to gas. And we have also studied like pressure and temperature are the two important factors for the change of state. But children, do we always need to heat or change pressure for changing the state of matter? Now children, you can see in this figure the water in ocean, lakes, rivers, glaciers, everywhere, it is being converted into vapor. Do we change the temperature or the pressure over here? Or does the liquid always has to reach its boiling point to change into vapor? What do you feel? Is it there every time? Let's see. Children, what happens when wet clothes are hung in sun? You do it every day. Sometimes water is left uncovered. What happens? From the wet clothes, the water gets vanished. They get dry up. Where does it go? And that too, if water is also left uncovered, it also the level also decreases, is not it? If you have not experimented with this, you can do it at home also. Leave a bowl full of water with a mark for a few days in the corner of a room. Then after some days, you can see the level of water has gone down. Where did the water go? Yes, it vanished. Where did it vanish? Vanished into the air or atmosphere. And that too from the upper level. Children, this is known as evaporation. The process of conversion of liquid to its vapor state at any temperature below its boiling point is called evaporation. Special features of evaporation are, it's a surface phenomena unlike vaporization. Evaporation causes cooling effect. Children, by an activity, I will show you how evaporation takes place. Children, I have taken some peas in this beaker. Now these peas represent the particles of liquid. Okay, just you have to imagine it. And one thing we know, that particles of liquid are always in motion. But unfortunately, I cannot show you this motion. And children, you know that when particles of a liquid are in motion, they gain some energy. That energy is known as kinetic energy. You know this? Okay. Now, when the particles gain kinetic energy, they move with greater speed. And what happens? They collide with each other. These particles, when they move, they collide with each other. Okay, children? Now, what happens? The particles which are at the surface, top level at the surface, what happens? They gain more energy. On gaining, more energy, they try to break the force of attraction between other particles and they move out and they get converted into vapor state. Let me tell you why only the particles on the surface. Why not the particles here? Because children, try to understand, when you are seeing the particles inside this, inside particles are surrounded by many more particles and they are held together by force of attraction. Is not it? From all sides. But the particles on the surface, they are only held by the force of attraction by the particles just below it. They don't have any particles above them. So, when they gain more kinetic energy, it becomes easier for them to break the attraction, force of attraction, and release themselves and get converted into the vapor state. So, evaporation is a surface phenomena. Okay, children? Factors affecting evaporation. What are the factors which affect the evaporation? Let me tell you one thing. Before going to that, let me do one more activity. I'm spreading some more particles over here. See these particles? Consider these are the particles of the liquid. Okay, children? Now, we have liquid, imagine, in this beaker and in this tray. Okay? Now, since we have known that evaporation is a surface phenomena, from which surface evaporation will be faster and more? From these portion, these number of particles will get evaporated. Is not it? From this surface, see here, this surface, there are these number of particles which will get evaporated. Now children, just think, in which case, this case or this case, evaporation will be more. Yes, of course, the evaporation will be more from this because more number of particles are exposed. Okay, children? So, what do we conclude from this? Evaporation depends upon the surface area. The rate of evaporation of a liquid increases with the increase in the surface area. Children, you are seeing here this ocean. From the ocean, evaporation is much greater than in pond or well. So, larger the surface area, greater is the rate of evaporation. Let me tell you one thing. If I give you a piece of cloth, this is a wet cloth, children. See, water is dropping. Water is dropping. This is a wet cloth. Okay. I ask you to hang it in the sun so that it gets dried. Okay. How would you do it? Would you just hang it this way? Oh, I have an option. You can do one more thing. You can open this, okay, and hang this way also. Which option is better option? You know it? Yes. If I hang it this way or this way, it is a better option. Why, children? Because here more surface area is there and it takes less time to get dried. Rate of evaporation is more in this case than when we fold the thing when we hang it. Because here the surface area exposed to sun is less. Now I think you are clear. Children, next factor is temperature. We have studied earlier that With the increase in the temperature, the kinetic energy of the particles also increase. I hope you remember that. When the kinetic energy of the particles increases, what happens? The speed increases, collision increases, and that too, evaporation also increases. So, rate of evaporation of a liquid increases with the increase in temperature. So, it's a general experience that on sunny days, on hot days, our clothes get dried up easily than on misty or cloudy days. Is not it? Children, one more important factor, that is humidity. Now let me tell you what is humidity. It is the amount of water vapor that is present in the air. One more thing, let me tell you about humidity is that the air in the atmosphere has limited capacity to hold the water vapor. It has a maximum limit up to which it can hold it. Okay. So, where it cannot exceed that limit. Children, when there is a rainy day or cloudy day or misty day, what happens? There is a large amount of water vapor in the air. So, it has less capacity to absorb water by process of evaporation. On those days, it takes longer time for our wet clothes to get dried up. You might have experienced those things. Even on a humid day, what happens, children, you know, if you are sweating, you feel some sticky feeling is there. Why this feeling comes? Because the sweat which comes out from your body doesn't get evaporated or dried up due to more amount of water vapor present in the atmosphere. So children, what should be our conclusion? When humidity is more, evaporation is less. Yes, the rate of evaporation of liquid decreases with the increase in humidity. Children, rate of evaporation also depends on wind speed. Now in many of the states, monsoon is set in. Now, you might experience in your day-to-day life that clothes you cannot hang it outside. Why? Due to rain. So what you do generally? We generally put it under fan so that with the wind or the air, the water vapor blows away, okay, making space for more water to be evaporated. The wind speed also increases the rate of evaporation. You can see in this picture how they have hung their clothes inside the room. One example just struck to me. I can give you an example. Have you ever traveled by train? You might have seen people. They're just hanging their wet towels outside the windows of the train so that it gets dried up quickly. Why this? Because when they are hanging the towel outside, it is blown by the wind and gets dried up quickly. Now, very important concept. Evaporation causes cooling. Before that, I want to tell you one thing. Many of you might have used spirit on your body parts. Or you might have known about acetone. What is that? It is the nail polish remover. Girls might be using that. Children, when you put that nail polish remover, you feel certain area has become cooler. Is not it? And after some time you see that nail polish remover has vanished. Generally you say, don't you, that don't keep the bottle open. What will happen? It will vanish. Does it really vanish? I'll put this nail polish remover here. This is acetone. Okay, I'm putting in this beaker. See here? You have nail polish remover here. I'm not touching it. But let me keep it aside and we'll see after some time that it has vanished. Why? Where did it go? We'll learn about it. I'll close it, otherwise this will also vanish. And I'm feeling cool when I'm using it. Children, now in summer, you might have seen in many of places you find this earthen pitcher where you store some water, because people say water remains cool. Why not in a brass container, or aluminum container, or a steel container? As soon as summer sets in, you put a earthen pitcher, because earthen pitcher has holes in that is pores are there in the earthen pitcher. What happens? Through these pores, the water gets evaporated. Okay. Now children, you know that when evaporation occurs, what will happen? It needs more energy. Where does this water gets energy from? Water collects energy from its surrounding area. And what is the surrounding area here? It gets energy from the water inside the pitcher. When water gives energy, water is left with less amount of energy. That is, in other words, it is cool. Comparatively, water is cooler inside a pitcher after evaporation. I hope you get my point. Let's go for one more example. That is on the screen. You can see the sweat. Okay? When does a person sweat? Sweating is there when you do some rigorous exercise, running, jogging, etc. All these type of things. Your body gets heated up, is not it? When your body gets heated up, the sweat comes out. And it's a natural phenomena. Sweat gets evaporated. And for this evaporation, it needs energy from surrounding, that is the body. It takes heat from the body. The sweat, that is the liquid, takes heat from the body and gets evaporated. And the body feels cool because heat has gone. Okay, children? Let me give you one more example which we do in day-to-day lives. Children, on hot summer days, what happens you know? The roofs of our houses get heated up a lot. So the rooms also get heated up. What we do, children, then? We wet the roof with water. As you see in this picture, we put water on the roof. So what happens? When we put water on the roof is already heated up. The water very soon gets evaporated by drawing the energy from the roof or the heat from the roof. As a result, the roof becomes cooler and hence our rooms. This is why we put water on the roof on hot summer days to keep ourselves cool inside the room. Okay, children? Now, see here, the amount of acetone is decreasing. It's some few drops are left. I'll see later on. Now we have understood what is evaporation and we have known boiling. Now let's learn boiling versus evaporation. Children, we'll compare boiling and evaporation on basis of certain parameters. First, let's learn the definition. Steaming or bubbling up under the action of heat is boiling. To change from a liquid or solid state into vapor is evaporation. You can see this, boiling and evaporation. You can see the bubbling water and evaporation. Here how it is being, liquid is evaporated from the fields and gases you can see over here. Then comes movement of particles. Boiling creates an extremely rapid movement of water particles, and here in evaporation particles are always moving but at a much slower rate than boiling. Boiling is a unnatural process, whereas evaporation is a natural process and is the first step in water cycle where it occurs. It occurs throughout the liquid, that is boiling. But evaporation, as I have showed you in the activity, it is a surface phenomena. Boiling takes very less time, whereas evaporation takes very longer time. More amount of temperature, more temperature is needed for boiling, whereas evaporation requires less change in temperature. What about energy? Boiling needs more energy than evaporation. The summary of boiling and evaporation. Evaporation occurs on the surface of liquid, whereas boiling occurs at the entire length of the liquid. Boiling occurs rapidly, whereas evaporation occurs slowly. Evaporation occurs at a temperature, whereas boiling occurs at a specific temperature. Next, the motion of the particle is fast in boiling, whereas in evaporation, few particles move slowly and few at a faster rate. Next point is, there is formation of bubbles in boiling, but bubbles are not seen in evaporation, as we have seen in a picture. Then a new concept comes, children, that is condensation. What is condensation? Condensation is the change of the physical state of the matter from gaseous state to the liquid state and is reverse of evaporation. Children, here you see the picture of a glass having ice cold water. Why do we see water droplets on the outer surface of a glass containing ice cold water? Let's see here also. I've got some ice cold water. Let me put it in this glass. Even on this bottle also, you can see the droplets here. Droplets, it's falling down, droplets, marks. And after some time here also you see it is misty and foggy. In this glass also you see misty, foggy, I can draw lines over here. Droplets of water are seen on the glass. Why this happens, children? Let me give you some hint. These are observations you would have observed, but you have never thought why this happens. This is because the air surrounding this glass or the bottle is in a gaseous state, that is, the vapor is there here. When this vapor comes in contact with the cold surface of the glass, what happens? When temperature decreases, what happens? Gases change into liquid. So, you find droplets of water over here. Okay, there is here which state? Gaseous state to the liquid state, and this process is known as condensation. Okay, children? Here in this question, children, A, B, C, D, E and F are the following diagram showing a change in a state. We have discussed this earlier also, but just a revision. Solid changes to liquid, A, when temperature is more. That process is known as, yes, you also recollect? Good, that is melting or fusion. Then liquid back to solid. It is solidification. Even we call it freezing. Liquid to gas on heating. That is known as boiling or vaporization. Gas to liquid, as you saw now, it is condensation. Children, skipping the liquid state, when there is a change of state from the solid to the gas, it is known as sublimation. And same, on decreasing the temperature and increasing the pressure, gas to solid, it is known as sublimation. Same, sublimation, both way. One more interesting question, children. Just look at your screen. You have 4 containers, okay? A, B, C, D. In which of these 4 containers evaporation is highest? Make a guess. It seems D has got more surface area, is not it? You think D? No, it's not D because D is covered. Evaporation cannot happen here. Then let's compare A and C, which shows nearly equal surface area. But what is your answer, children? My answer is C. Why? Because it is nearer to the fan and wind speed is more, so evaporation is also more. Children, as I have discussed earlier, the fourth state of matter is there. We had studied three states of matter: solid, liquid and gas. The fourth state is the plasma state. Children, when solids are heated up, it gives liquid. When liquid is heated up, it turns to gas. When gas is superheated to a very high temperature, it gives a plasma state. Okay? Plasma in sun and many stars, you find this plasma state. How this plasma state occurs? This is due to the ionization of the gases. What is ionization? These gases at very high temperature, they give out positive and negative particles. And especially when this gas ionize, they glow. Okay? That is why suns and stars, they glow. In your daily life also, you might have heard this word plasma, plasma screen, plasma TV, plasma this so and so. Here also on Earth, we are using this technology. You might be having tube lights at your home. What is that? It works on plasma technology. Those tube lights have helium gas inside that. When electricity passes through that, it ionizes and gives a white color light. Okay. Similarly, neon lamps, argon lamps give different color, yellow color lights because different gases have different characters and depending on their characters, they glow. Okay. As you see, plasma is not a common state of matter here on Earth. But it may be most common state of matter in the universe. According to Jefferson Laboratories, stars are essentially superheated balls of plasma. Plasma consists of highly charged particles with extremely high kinetic energy. Gases like helium, neon, argon, krypton, xenon and radon are often used to make glowing signs by using electricity to ionize them to the plasma state. Examples of plasma, as I have discussed, it's lighting. Here the ionization takes place. These things you have learned in, I think in class 8 or 7 it was there, about charge of lightning. And suns and stars also work on this. There is ionization of gases over here. Now, let's learn about the fifth state of matter. That's beyond your course, but I want that you should know this also. In 1920, Indian physicist Satyendra Bose had done some calculations for a fifth state of matter. Based on his calculations, Albert Einstein predicted a new state of matter, the Bose-Einstein condensate, BEC. BEC is formed by cooling of a gas of extremely low density, about 100,000th of the density of normal air, to super low temperature. This is all about Bose-Einstein condensate. When you grow up, you learn more about it. Children, now it's time to strain your brain. Just give a thought to your brain. Why does a desert cooler cool better on a hot day? Should I give you a hint or you know this answer? Please take down this in your notebooks. Evaporation is more on hot days because temperature is more. Okay? Why does our palm feel cold when we put on some acetone or petrol or perfume I have discussed, children. Even I told you, see this, acetone has vanished. This is because acetone gets evaporated, and when we put it on our palm, it takes heat from our palm and gets evaporated, and palm feels cooler. Our next question, what produces more severe burns? Boiling water or steam? I discussed in last classes. But let me give you one more hint. Boiling water and steam at 100 degrees centigrade. Steam has more energy than water, so it causes severe burns. Latent heat of vaporization. Try to remember that. What type of clothes should we wear in summer? Children, we should wear light colored cotton clothes in summer. Why light? It reflects more. Why cotton? Cotton has got pores. It will absorb the sweat and get evaporated, and our body will remain cool. Okay? What is the first state of matter? Yes, just now we heard it. It's plasma. Plasma is the first state of matter. So, with these questions, children, I conclude today's chapter and even the first chapter, the matter in our surrounding. I hope you have understood. Please go through your book. Read that lesson repeatedly. Okay, children? Take care. Take care of your elders. Stay home. Stay safe. Thank you.